Welcome our project on designing and development of an application for an spot assessment of rooftop rainwater harvesting and artificial recharge potential and the size of the RTRWH and AR. Our front end is built using React with TypeScript. The entry point is index.html which loads our React app. Inside the source folder, the main file is main.tsx which renders the app.tsx. We have multiple components in the components folder. For example, location selector.tsx allows user to choose a district and a subdistrict. New home form.tsx and the existing home form.tsx collect details like roof type and roof area. Results TSX displays the predicted rainfall and harvesting potential. MapView TSX provides a geographical view. Sidebar TSX and layout.tsx manage the dashboard design. The front end sends user input like district, subdistrict, roof type, and roof area to the backend through an API call using the fetch function. Here is our backend code explanation. The backend is built using Flask in Python. We first load the dataset districts rainfall.csv, which contains rainfall data for different districts and stations. This dataset consists of serial number, department, district, subdistrict, rainfall values, and date. We totally have 6,50,618 data. This data is taken from TN Smart webpage. This is our backend file app.py. The user data from frontend is received at the predict route. We use pandas for data processing, extracting the year from rainfall records and calculating yearly averages. For prediction, we use linear regression from scikit-learn. The regression formula is y equal to m into x plus c, where y equal to predict rainfall, x means year, m means slope of the regression lines, and c is intercept. This allows us to predict rainfall for future years, especially from 2025 to 2036.